So welcome all of you. In this video, I will give you an idea about the two-dimensional truss problem in Ansys. So this is Ansys 2021 academic version. So first of all, I will go with this. This is the command prompt. Here you can see the graphical user interface. GUI is there. So I will use the command prompt. This is the command prompt. Okay. So I will enter the title slash title truss tutorial. Okay. So here you can see the truss tutorial is displayed here. Here you can see the truss tutorial is displayed here. Then okay, or you can use like this. Okay. So I have entered the title, truss tutorial. Then I will enter the preprocessor phase, that is /prep7. That means now I am in the preprocessor phase. Or you can select from here, this is the preprocessing phase. Here I will enter height. Height is equal to 3118. Then I will enter the width. Width is equal to 3600. Okay, I have entered the height and width. Then I will enter k comma 1 comma 0 comma 0. That is key point number 1. Then k comma 2 comma. Then I will enter width by 2 comma height. Then next is k comma 3 comma width comma 0. Then k comma 4 comma 3 into width by 2. So 3 into width by 2 comma height. So here you can see 1, 2, 3, 4 key point. Then k comma 5 comma 2 into width. 2 into width comma 0. That means you can see key point number 5. Then key k comma 6 comma 5 into width by 2. 5 into width by 2 comma height. So here you can see key point number 6. Then k comma 7 comma 3 into width. 3 into width comma 0. So here you can see key points 1, 2, 3, 4, 5, 6, 7. 7 key points. The next is I have to define lines. So here in the GUI you can see modeling. Here you can see create key points option is there. So you can use this also. with the help of this key points, you can create this key points. Then define line. So L comma 1 comma 2. So here you can see a line is between 1 and 2. Then L comma 1 comma 3. Then L comma 2 comma 3. Then L comma 2 comma 4. Then L comma 3 comma 4. Then L comma 3 comma 5. Then L comma 4 comma 5. Then L comma 4 comma 6. L comma 4 comma 6. Okay. Then L comma 5 comma 6. Then L comma 5 comma 7. Then L comma 6 comma 7. Okay, so here you can see, so I will go to plot. Here you can see plot lines. Okay, so here you can see lines. If you want to see the key points, you can go with plot key points. So here you can see the key points. If you want to open the numbering, go to plot controls, numbering, then switch on the key point numbering and click OK. So here you can see the key point numbers. If you want to see the line numbers, go to plot controls, line. So line numbers. Okay, so here then plot lines. Okay, so here you can see L1, L2, L3, L4, L5, etc. So these are the lines. Okay. Then next is I have to define the element et comma 1 comma link 1. Et comma 1 comma link 1. Okay, so here you can add this element type using this element type. Here you can see the link 1 is displayed. Okay, then the next is r comma real constant. So r comma 1 comma 3250. That means here the area is given. Area is 3250 mm square. So 32 r comma 1 comma 3250. Okay, so that means the real constant cross-sectional area is 3250 mm square. Okay, enter. Then next is MP comma EX comma then 1 comma 200 E3. That means this is the Young's modulus 200 E3. Okay, so here you can see the material properties. Go to material models, then structural, linear, elastic, isotropic. So here you can see EX value is there. Here you can see EX value. So 2 into 10 raised to 5. Here you can see. Okay. Okay. So here in this way you can add this Young's modulus. The next is the meshing. So for meshing, LE size, comma, all 1, 2, 3, 3 commas, then 1 comma 1 comma 1. Okay, then L mesh all, then L mesh comma all. Okay, so that means meshing completed. Okay, if meshing is completed, you please check. Go to plot controls, then numbering. Then I will switch on the node numbering. Okay. Okay, so here you can see the nodes. So these are not key points. These are the nodes. 1, 2, 3, 4, 5, 6, 7 nodes. Okay, if you want to see the key point numbering, just on the key point numbering. Plot key points. Okay. So if you want to see the nodes, so here this is the node and plot controls. Go to plot controls, numbering and nodes. Okay. So meshing is completed. If you want to use this here, you can see meshing is there. You can use this option. You can mesh this. Okay. Then I will enter the finish button. Finish. Finish. Okay. So now, if you want to go to the preprocessor phase, you just prep7. Enter prep7. Type prep7. Click enter. So here in the bottom you can see pick a menu item or enter a command prep7. So this is the pre-processing phase. If you want to finish this, just click finish. Okay. The next is the solution phase. Okay, the second phase. From here you can select the solution phase. So here I am using this command prompt /solu. That means solution phase. So here in the bottom you can see pick a menu item or enter a command solution. So that is the solution phase. Then apply constraints, that is dk comma 1 comma all comma 0. That means degrees of freedom. Constraint at key point number 1. All x, y and z. Okay. So here you can see a triangle at key point number 1. 2 triangles. That means this is constraint. Then next is dk comma next point is 7. This point is 7. Next endpoint dk comma 7 comma uy comma 0. Okay, that means uy only, y axis. So x axis movement is there. That means the roller support. X axis movement is there. The next is apply loads. That is fk comma 1 comma, that is now key point number 1. Then fy means force in the y direction, minus 280 e3 minus 280 e3. Okay, so here you can see a red arrow in the downward direction. Similarly, fk comma 3 comma, that is key point number 3, and fy minus 210 e3 minus 210 e3. Okay, so here you can see key point number 3. Then fk comma 5 comma fy comma minus 280 e3 minus 280 e3. Okay. So here key point number 5. Then next is key point number 7, fk comma 7 comma fy comma minus 360 e3 minus 360 e3. Okay, so here 4 forces, 1 2 3 4 at key points 1 3 5 and 7. Okay, so here you can analysis type is static. Okay, so preferences structural analysis. Okay, then here you can apply load. Here you can define loads, apply structural. So here you can see you can add the displacement. Then you can, if you want to add the force, you can add the force using this option. Okay, so both are same. Then next is the solution. Then I will enter solve. Okay, that means solution is done. Then I will again enter the finish. That means I am actually exiting from the solution phase. The next is the third phase, that is the post processing. So /post1. That means in the bottom you can see post1. This is a pick a menu item or enter a command post1. Okay. Then I want to see the reaction forces. For reaction forces, I PRR SOL, comma F. Okay, you will get the reaction forces. So here you can see this is the reaction forces, reaction solutions per node. That is this is node number 1. The fx value is this and the fy value is this. And node number 7. This is node 1 and this is node 7. Okay, you can see the reaction forces. Okay, so in other way, you can take the results from sorry, result summary, not result summary. Okay. So list results, reaction solution. Yeah, all items. Yeah. Okay. So here you can PRRSOL, comma F. Okay. So here you can see the solution. Otherwise, you can go with the general post processor, then list results. Here you can see the reaction solution, then all items, click OK. So you will get the same result. Okay. Then next is the plot deformed shape. That is PL disp, comma 2. PL disp, comma 2. You can see the deformed shape. Okay. And here you can see the maximum deformation DMX 7.40925. This is the maximum deformation. If you want to see the animation, go with this plot control, animates mode shape, and click OK. And so here you can see this point is fixed, and this is roller support. Y movement is constrained. Okay. Okay. So the maximum deformation is DMX, that is 7.40925. This is the maximum deformation. So if you want to see the deformed shape, that is PL disp, comma 2. Okay. So this is the deformed shape. Then contour plot of deflection. If you want to see the contour plot of deflection, that is PL NSOL, comma U, comma sum, comma 0, comma 1. Okay. So you can see the contour plot of deflection. Okay. So you can see the DMX value, you can see the SMX value. Then next is the axial stresses, E table, comma SAXL, comma LS, comma 1. Okay, so here this is not available. So then element table, pre-tab, I will check pre-tab, comma. Okay, so no element items is available. Okay, so the three results. One is the reaction forces, that is PRRSOL, comma F. Okay, so that is the reaction forces, node number 1 and node number 7. And the second is deformed shape, that is PL disp, comma 2. Okay. Okay, so here you can see this is the plot deformed shape, and then the last one, contour plot of deflection, PLN comma U, comma sum, comma 0, comma 1. 0, comma 1. Okay. So that is the first problem on truss. Okay. So here this is the truss, and you have to find the nodal deflections, reaction forces, and stress. Okay. What about the nodal deflections, the reaction forces, and the stress? Okay. Here the Young's modulus is 200 gigapascal, and the cross-sectional area is 3250 mm square. Okay. So first you have to model this truss using this pre-processing phase. Then you have to add element type, real constants, then the material properties and meshing. Okay, so that was about the pre-processing phase. The next is go to the solution phase. You have to which type of analysis, static analysis or which type of analysis. Then go with this load. Okay, you have to apply the structural displacement load. Okay, or if you want to add a force, you can add force, or pressure, temperature, etc. You can add defined loads. Then next is you have to solve current LS. Once the solution phase is completed, go with the post processor, and here in this section you will get the results. Okay, so that was an idea about the first problem, that is truss. So practice this problem. Thank you.